welcome back to my channel and let's learn chemistry. Today we are going to learn a topic related to the atomic orbitals, the subshells, and I have one assignment for you. I hope you would be able to answer these one as you might have watched the previous video. If not, go back to the previous video of the electronic configuration and electronic structure and then solve these one and do answer me in the comments. So these are the questions for you. You have to write the electronic configuration of potassium, calcium, gallium and the potassium ion. Let's have a look how much you have understood about the electronic configuration. Let's move to our main topic, that is the our learning goals, and the very last topic that we are left with is ionization energy. So we have discussed particles in the atom and atomic radii, and we are now again going to revise this atomic radii as we have to discuss the ionization energy. Then we have discussed isotopes and how to calculate the relative atomic mass. We have discussed the electrons, energy levels, the subshells, shells, and now in this video we are going to discuss the ionization energy. So let's move to ionization energy. What is ionization energy? As the name indicates, it has to do something with ionization, mean the ion formation. Now, how do we define the ion formation or ionization? It is actually the amount of energy that is required to remove an electron. Clear? In simple words. Now let's define it a bit scientifically. So this is the amount of energy to remove 1 mole of one electron at a time, basically from 1 mole of gaseous atom. This is very important. We have learned this in the relative atomic mass as well, that when we calculate the relative atomic mass or when we have to use the mass spectrometer, we first have to ionize the sample. So before ionization we have to convert our sample into a gaseous state, because it's easy to remove an electron from a gaseous state. So when we talk about the liquid state or the solid state, they might be in like bonding can affect our values. Bonding, because if the bonding is very strong, definitely the ionization energy would be really high. If the bonding is weak, the definite ionization energy would be low. For example, if we take an example of HCl and H2, the bonding in HCl is quite, like, say, stronger as compared to H2. So we cannot calculate the ionization energy in the bonding of hydrogen in the bonded form. That's why we need to take a gaseous atom, not a molecule, a gaseous atom of hydrogen. So there would be a single atom that is not under the control of any other outer energy or outer attraction. So first of all, we convert them into gaseous state and then we remove the electron. So we have a gaseous ion. So that amount of energy which is actually required, so it would be endothermic process. That would be ionization energy. So what are the units? The units are kilojoules per mole, means 1000 joule. The value of ionization energy is always positive. As we've discussed, it's an endothermic process. A lot of energy is required to remove or pull out the electron. For example, you can say the nucleus is the mother or the electrons are the children. Definitely, it's very difficult to take the children if the mother is there. So a lot of energy is required. The kidnappers may have to plan a lot and they have to put in a lot of energy. So the ionization energy for magnesium, let's say, so magnesium is in group number 2. Let's write as electronic configuration. It would be first shell would have 2, second shell would have 8 electron, and third shell would have 2 electrons. Now it want to have the electronic configuration of the nearest noble gas, or want to have a stable electronic configuration. It want to have 8 electrons in the outermost shell. So it has 2 ways. Number 1 way, it can give 2 electrons to someone else in a complete shell, balanced life. Okay. Second, it can accept 6 electrons. Definitely, it's very tough to accept 6 electrons. They have to go to 6 different atoms. They need to back for the electrons. So they better thought, okay, let's give these 2 electrons to something else, to some other atom. So these 2 electrons are lost, but one by one, not at a time. They are not going to be lost, like one by one. So to remove the first electron would we would have and then we need an energy of 738 kilojoules per mole. Now the electronic configuration would become 281 because the electron is lost. One electron has been given off. Now the second ionization energy would be 1451. Now it would have an electronic configuration of 28. Now look at the difference. Less energy is required to remove the first electron, while more energy is required to remove the second electron. Why is this so? Consider this. There is a mother who has two children. It's you already put in so much effort to kidnap the first one. Now to kidnap the second one, you need to put in more efforts. Definitely the energy would be very high because now the mother has more surveillance over the second one. So you need to put in more, or the kidnapper need to put in more efforts to take that electron or take that kid out. So when the nucleus, now nucleus would have 12 protons, it have a control on 12 electrons over here. Let's say 12 electrons. One electron is lost. Now 11 electrons are left. This proton would have much higher control or much higher nuclear attraction for these 11 electrons. It would be really hard to remove the other electrons. That's why the energy is needed. So ionization energy is the qualitative measure of the stability of an isolated atom. Ionization energy means higher stability. If you need to take an electron from a stable compound, you need to put in more effort, you need to put in more energy. So that's why the ionization of energy of neon is 2081 kilojoules per mole. Why? Because it has a stable electronic configuration. The outermost shell is complete, so it's difficult to remove the electron. Now what are the different factors that affect the ionization energy? Let's discuss, like why some atoms have low ionization energy, some atoms have high ionization energy. Why is this so? Number one is the atomic radii. Okay, let's take this an example of a class. So if we have like 4 rows, the backbencher can easily move out of the class because he or she is sitting far away from the teacher. The radius is really high. The teacher has less control, or the nucleus has less control on the outermost shell. So they are like easily removed. While if to take electron from the first shell or the second shell, the nucleus have more control in them. So it's difficult to remove the electron from a smaller atom or the atom with less number of shells. It is easy to remove electrons from the atom which have more number of shells. So greater the radii mean the less ionization energy. Clear? Smaller the size, high ionization energy, very difficult to remove the electron. Now the nuclear charge. As we have discussed previously as well, if the nuclear charge is very high, for example in magnesium, when the one electron is taken off, magnesium plus 1, the nuclear charge is very high now, you need to put in more energy to take the second electrons. So more or higher the nuclear charge, higher the ionization energy. Simple. It's directly proportional. Third one is the shielding effect. Now, how shielding effect? Now, if we have, for example, 3 shells and we have 5 shells, which would have more shielding effect? Definitely the 5 one, because it has inner 4 shells. It has 2 inner shells. This would have more shielding effect. Shielding effects mean the attraction between the outer electron and the nucleus becomes less. As the number of rows or number of benches increases, the attraction becomes weak. Clear? And the last one is the nature of orbital, like whether you're removing it from D1 It's easier to remove from D1 because they have very high energy. They can move from one orbital to another orbital. It is very difficult to remove it from the s orbital because they're quite closer to electrons, to the nucleus. Now the variation, how they differ in the periodic table. So when we move from left to right, the size decreases. You are well aware with this fact. The size decreases. When the size decreases, it means the ionization energy increases. As we discussed earlier, that if the atomic radii is bigger, it is easy to remove electron. If the atomic radius is small or the size is small, it is very difficult to remove the ionization, to remove the electron. So the ionization energy is high. So if you look at this trend, look over here, it's increasing along the period. So there are certain dips. Why there are dips? Because these are actually the ones with the even number. Like when we talk about their spins, that's why their energy is lesser. The increase in nuclear charge, they pull the electrons strongly, and smaller radius mean electrons are nearer to nucleus, they have more attraction, so they are difficult to remove. Shielding effect does not increase, mean the number of inner shells remain same, so it has no effect on this one. While we move from down the group, definitely these things are going to change. So let's talk about down the group. So down the group, they decreases. Look over here, down the group, sorry, it's down group, not a long group. So down the group, it decreases. Why? Because the size is becoming bigger, the attraction becomes weaker, so it's easier to remove the outermost electron. So decrease in the nuclear charge, decrease in the attraction, force of attraction. Largest radii mean, again, very far away. Shielding effect, there are a lot of inner shells that are preventing the outer electron to make bond or to have an interaction with the nucleus, and the number of shell increases, so the size of atom also increases. It means the ionization energy decreases. Simple. Okay, let's talk about the successive energies. We have discussed it earlier as well, that the if magnesium is there, the first ionization energy would be less, the second would be much higher because of the increased nuclear charge. So why it is removed? Why it is more? Because the more electrons are removed, the shielding decreases, the proton to electron ratio increases. We have discussed it earlier. The attraction between nucleus and the remaining electron increases. These are the certain reasons. Let's talk about the calcium. Now look over here. To remove the electron from the outermost shell, it's very easy. The energy is very high. We need less energy, sorry. We need less energy to remove the electron from the 4s1. But if we want to remove electron from 1s, we need to have much higher energy. Simple. It's easy to remove the first electron as compared to the very inner one or the outer one. Outer electrons are easy to remove than as compared to the inner ones, and you know the answer, that they have high nuclear charge, they have more attraction towards the nucleus, they have more charge, to charge attraction, they are under the control of the nucleus, so they are very 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 tough to remove. And this is all about ionization energy. I hope you understand this concept really well. So if we put this into words, how do we say that? The first ionization energy is relative low. Why? Because of the pair repulsion. One is clockwise, other is anti-clockwise. The second electron is harder to remove because now it's a single one. It has no repulsion. There is no anti-clockwise. The third ionization energy increases sharply because now you have to remove from the inner shell, which is much much closer to the nucleus. And the fourth electron is much more difficult to remove because the spin pair repulsion uh, within the p orbital is very high. So the successive ionization energies always increases because electrons are being removed from an increasingly positive charge, and definitely as the positive charge increases, the proton would have more control on electrons and they're difficult to remove. I hope you understand this video. I hope you understand this concept. See you in the next video. Bye bye.